All right, so final video here on just the pulse source and kind of doing a transient simulation. Um, let's say I want to make my transient sim. Let's make it a little bit longer so we can give ourselves some more time here to do stuff. 20 milliseconds is plenty. And then what I'm also going to do is I want to show you that. So I reduced the x-axis from 0 to 10 down to 1 to 7 milliseconds. So here I'm going to just hit this button here that they have. It basically just undoes all the changes that you made to the settings. It says zoom to fit, but what it does is it really just gets you back to the beginning. Any settings that you change, it'll take you right back. So if I hit F9, it undoes that. If I click it again, it takes me back. And then again, I can click F5, my delete, and I can get rid of my arrow, get rid of my text field, and now I'm right back where we started. Okay, and so what I want to do is I want to show you how to. And so obviously the 20 milliseconds hasn't changed anything yet because I haven't rerun my simulation. I'm still looking at the data that was generated from my 10 millisecond run, right? So if I just run this 20 milliseconds, now you can see that it just shifted us down to a sim from 0 to 20 milliseconds rather than from 0 to 10 milliseconds with the exact same pulse. But if I come back over to my pulse source, I can make some changes here. Like I said, I want to make this thing periodic. And so to make it periodic, what we typically do, let me come back in here actually, we can set the period, which is how long do we want a single cycle to take, right? So let's just say I want a single cycle. I'm going to change a lot of stuff here. Let's say that I don't want any delay now, or actually I'll delay for 1 millisecond. I'm going to make my rise time and fall time very fast so that they're just a very small portion of this plot. Let's take it down by an order of magnitude, or sorry, 3 orders of magnitude, and let's make it a nanosecond rise time and a nanosecond fall time. So now we should see very little slope here because it's going to be almost infinite. It's going to be rising so fast that we can't even tell that there's any time there when we're looking at it in milliseconds. Okay, and then we'll leave it on for 1 millisecond. Okay, and then we will make our period 2 milliseconds. Okay. And so it's going to be on for a millisecond and then off for a millisecond. And we won't put any number of cycles. If we don't specify the number of cycles, then it'll just keep on repeating. Okay, so let's go ahead and do this and we'll just run this simulation. And there is my window. It looks like just a bunch of vertical lines, but I can assure you that there is some order to this. And this is where it becomes useful to change the plot so that we can actually see the top and bottom here. So I'm going to do that again. And there's my pulse train, or my what we would call a square wave being generated by this pulse source. You can see that. Again, we started at 0. We delay by 1 millisecond, and 1 millisecond later, we rise up to 5 volts. It's very sharp because I made my rise and fall times 1 nanosecond. It stays high for 1 millisecond, and then it comes back down and it completes the period for another millisecond, right? So my period is 2 milliseconds, which is this time right here, and then it repeats. It does the exact same thing. And so that is what a periodic signal looks like. If I made my period longer, so let's say I make my period 3 milliseconds and I rerun, okay, so I need to change my axes again, which is pretty frustrating, but I'm gonna do it again anyways just so that you can see. So now it's on for 1 millisecond and off for 2 milliseconds because my total period is 3 milliseconds and I still only have my on time set to 1 millisecond. Okay, so hopefully that makes sense. The last thing I want to show here is that I can specify a number of cycles and then it won't repeat like this. It will do that number of cycles and then it'll call it a day. So if I just want to set the number of cycles to, let's say, 4, I can go ahead and do that and I can hit run. And now I only get 4 cycles and then it finishes and nothing else happens for the rest of the time. Okay, again, really frustrating that I have to keep editing the bounds of this plot, but I'm doing it just to make it look nice for these videos. It's not necessary, but yeah, so that's pretty much everything I wanted to show about the pulse source. I think it's really interesting, very useful to know. Actually, I think I'm going to make one more request for you to remember this. Let me do one more thing here that I haven't done yet. I can make a single pulse that goes up and just stays on and never turns off by setting my on time. So no matter what all these other things are, if I set my on time to be longer than my simulation time, so let's just say I say 30 milliseconds, right? I'm only running for 20. If I run this, what did I do? Maybe I set the wrong, oh, I set the delay time to 30 milliseconds. Okay, so let me undo that. My on time to 30 milliseconds. And now my pulse will just stay on. It will never turn off. And so this is very useful for RC circuits. Man, I really am getting frustrated by the fact that I have to do this every time. Okay, so I turn on and I stay on for 30 milliseconds, but since I'm only running for 20 milliseconds, none of the other things ever even come into play because all of this stuff, the fall time and the 4 cycles is happening so much further down the line. If I wanted to see all that, I'd have to run for a much longer time. So let's run for 200 milliseconds just so we can see that that's actually what's happening. Again, I have to change the plot. I'm sure there's a way to change it by default. But now you're seeing that I'm on for 30 milliseconds. And since my period is only set to be 3 milliseconds, it's actually just jumping down and then jumping straight back up. I don't think there's any time here. This width is probably negligible. We can check it out by drawing a box, and that actually zooms into a part of the sim. And you can just keep zooming in as far as you want, and you can actually see that there's just no width to that pulse. It basically jumps down and comes immediately back up because I made my on time longer than my period, which is technically a violation. I mean, that just makes no sense. Okay, so I'm going to go ahead and end this video here, and in the next video, I'll probably get into an RC circuit example or some kind of a first order circuit example.